Hello friends, welcome to the Why Things channel. Today, we're diving into the most fascinating secret of the night sky: why do the stars shine? When you look up at the sky and see those sparkling lights, have you ever wondered where that brightness comes from? Are the stars the lamps of the universe, or is there some other magic at work? In this video, we will discover how the stars shine, why they appear in different colors, why they pulsate, how they illuminate the history of the universe, and why they are so fascinating for humanity. If you're ready, let's embark on this cosmic journey and unlock the magic of the stars. 1. The secret of stellar brilliance, the power of nuclear fusion. Why do stars shine? The answer lies in their core. At the center of stars, there are temperatures of millions of degrees and incredible pressure. In these conditions, hydrogen atoms combine to form helium. This process, nuclear fusion, converts some of the mass into energy. This is where Einstein's famous E=mc² equation comes into play. This energy is radiated into space as light and heat and makes stars shine. For example, our sun converts 4 million tons of mass into energy every second. This has kept it shining for 4.6 billion years and will keep it shining for the next 5 billion years. Imagine, without this energy, plants would not be able to photosynthesize and life on Earth would not be possible. Stars are the power plants of the universe. But that's not all. Fusion produces heavy elements, carbon, oxygen, iron, inside stars. These elements will one day be ejected into space in supernova explosions, creating new stars, planets, and even us. 2. Colors and brightness, identity of the stars. So why do some stars shine blue, some red, and some yellow? It depends on the temperature and chemical makeup of the stars. Hotter stars emit more energy and appear blue or white. Cooler stars have a reddish glow. Here are a few examples. Rigel shines blue-white with a temperature of 12,000 K and is a young, energetic star. Our Sun, a yellow star at 5,500 K, is middle-aged and stable. Betelgeuse, a red supergiant at 3,500 K, is old and massive. The brightness depends on the size of the star and its distance from Earth. Astronomers measure the apparent brightness of stars as apparent magnitude and the true brightness as absolute magnitude. For example, Sirius is the brightest star in the night sky because it is small but close to us. Betelgeuse, on the other hand, is huge, but 600 light-years away, so it appears dimmer. An interesting detail: if Betelgeuse were in Sirius' place, it would light up the night sky like day. The colors and brightness of stars reveal their age, chemistry, and evolutionary stage like an identity card. 3. Flicker, the cosmic dance of the atmosphere. When you look up at the night sky, you may have noticed that the stars flicker. But why does this happen? Actually, the stars shine steadily, but the Earth's atmosphere distorts the light. Air turbulence, winds, temperature differences deflect starlight in different directions, which makes them appear to blink. This effect is especially pronounced for stars near the horizon, because the light passes through more layers of atmosphere. An interesting detail: because planets are larger and more stable light sources than stars, they usually don't flicker. So if you see light that doesn't flicker, you're probably looking at a planet like Venus or Jupiter. Space telescopes, such as Hubble or James Webb, see stars with crystal clarity because they are free from this effect of the atmosphere. Although the flicker adds a romantic touch to the magic of the stars, it's actually all a trick of the Earth's atmosphere. 4. Stellar evolution and the history of the universe. The brightness of stars varies depending on their life cycle. Young stars shine during a fixed period called the main sequence and consume their hydrogen fuel. But as they run out of fuel, they turn into red giants or supergiants. For example, our Sun will become a red giant in about 5 billion years, swelling up and becoming much brighter. Massive stars, on the other hand, emit enormous brightness in supernova explosions, sometimes dwarfing an entire galaxy. These explosions leave exotic remnants such as neutron stars or black holes. Stars also play a leading role in the chemical evolution of the universe. Supernova explosions produce heavy elements like carbon, oxygen, and iron. These elements enable the formation of new stars, planets, and even us. As the famous astrophysicist Carl Sagan said, "We are all stardust." Starlight tells the 13 billion year history of the universe. Some stars' light reaches us shortly after the Big Bang. By analyzing this light, astronomers unraveled the expansion, redshift, and chemical evolution of the universe. So, each star is both a power plant and a storyteller whispering the history of the universe. Here is the fascinating story of the brightness of the stars. Stars illuminate the universe with nuclear fusion, whisper their warmth with their colors, and tell the 13-billion-year history of the universe with their light. Their vibrations are the dance of the atmosphere, and their brightness is a reflection of their life cycles. Each star is both a power plant and a cosmic storyteller. Which star do you think is the most beautiful? Or what do you feel when you look at the night sky? Share it in the comments, we'll be curious to read it. If you like this video, don't forget to press the like button, subscribe to the channel, and turn on the notification bell. See you in the next why question. Don't forget to look up to the sky, because the stars are always there.